Hi, so there we have a homemade wind turbine brake system and how it works. Here we have two regulators for RPM and for the voltage. RPM is counted by this anemometer, and voltage is counted from the wind turbine. Let's try. Okay, so we have 22 volts coming from wind turbine. With the regulator on the controller I set voltage to be 24 volts, and then suddenly wind turbine starts to spin faster and voltage increasing. It hits the stage 1 and it connects. It's connecting the resistor, huge resistor. When voltage increasing more, it goes to stage 2, which is the same resistor but second coil on it. And if the turbine increasing voltage more, the relays connects another resistor, that way stopping the wind turbine. Also, controller is monitoring wind, and if I spin the anemometer, you are seeing RPM increasing. So let's say with the regulator I set some specific RPM, for example, I don't know, 100, and then wind is spinning the anemometer, and if it hits more than 107 RPM, the relays inside the controller connects the resistor to stop the wind turbine. What we have inside? So here it is, a rectified bridge. A three-phase wind turbine comes to it, and then it goes to Arduino Nano. It counts the voltage, RPM, and all the other logic, and if voltage is higher than set, it hits the one MOSFET, stage 1, the second MOSFET, stage 2, and the relays, stage 3. And that's it. I have tried to use PWM modulation for those stages, but it appears that it makes a lot of problems because PWM is making a lot of noise. That's why you are seeing those capacitors as a filters here, here, and here to reduce the noise which is coming from PWM, and transistors are hitting a lot when using PWM, so there is no reason for that. You can set just like a stages, and that way connect the dump load to the wind turbine. So I think this controller can handle about 200 watts on first stage, 200 watts on second stage, and 400 watts on the third stage, which is the release. And in total it would be something about 800 watts with no problem. This controller will be used with the on-grid system. So there is a wind turbine and there is a grid inverter, and this controller additionally will monitor if the turbine is spinning too fast and will slow down it. And then another function is that if the electricity will disappear, the relays will make a load on the wind turbine, and wind turbine will stop if electricity from the grid is off. It is not tested with the real turbine yet, but I hope that it will be tested soon. We'll see if it makes any difference or it will work same as on the bench. That's it. Like and subscribe if you like the video.